Okay, I wanted to give another example of solving linear systems by graphing, one that included a lot of fractions. So let's take a look at this example and see what can be done. The first thing I would try to do is clear these fractions just to see what we get. Maybe we can end up with some nice equations, some nice numbers, some nice round numbers. We'll see. I'm not sure though. So to clear the fractions, remember that for any given equation, you can multiply everything by the same number. That is, you can multiply the left side and the right side by the same number, and you haven't fundamentally changed the value of the equation. So, or the truth value of the equation, I guess I should say. So for this first equation, let me number it, equation number 1. I'll number this one equation number 2. And to clear the fractions for equation number 1, I am going to multiply every fraction by any common denominator that exists between all the fractions, considering both sides of the equal sign. Now, although any common denominator would work, meaning I could just multiply all these guys together, 3, 2, and 6, that would give me a denominator that works. Typically, try to find the lowest ones. It'll just keep the numbers smaller. So I noticed that 2 goes into 6, so does 3, so 6 is the lowest common denominator. I'm just going to multiply everything by 6. And this is how I like to notate that. I just put the entire equation in there, like so. Okay. And essentially what we're doing is we're distributing the 6 to everything. Now, 6 times 1/3, the way that I do that mentally, personally, you could do the 6 times 1 and then divide that by 3. Same thing over here, same thing over here. 6 times 23 and then divide that by 6. Or you can think of the 6 as the numerator of a fraction, 6 over 1. And when you're multiplying fractions, you can reduce any number on the top with any number on the bottom. And I like to reduce first. So for example, if I'm multiplying 6 times 1/3, in fact, let me just write it out so I can show you what I'm thinking. That's always nice, isn't it? That's why you should show your work on an exam, to show your instructor what you're thinking. Okay, here we go. All right. So preferably, I like to reduce first and then multiply, and that's okay when we're multiplying fractions. So I can reduce both of these by 3, right? This becomes a 2. I multiply that by what remains, the 1 on top, and so I get a 2x from that equation. From this first term of the equation, that is. The second part, I'm going to reduce this both by 2. This becomes a 3 times whatever's left up there, so I get a plus 3y equals on the other side. And when I reduce over here, I'm just going to cancel those guys out, and I'm just left with 23. Okay, so here's my new equation number 1 after having cleared the fractions. Let's take a look at equation number 2 and clear those fractions. So what is the common denominator here? Looks like 14 is the lowest common denominator, the lowest number that is divisible by all those denominators that we see. So let me multiply everything by 14. 14, here, let me just put a little dividing line so I don't get too confused here, times equation number 2, which is 1/2 x plus 1/7 y equal to 19/7. Okay. And again, essentially I'm distributing the 14 to everything, even across the equal sign, which is essentially the same as multiplying both sides by the same thing. And let me just write out what I get here. Since I showed what I was thinking over here, my equation number 2 will become 7x plus 2y equals 38. Okay. 19 times 2 is 38. I got that too by reducing these guys. So there's my equation number 2. Now, those equations are the solution of the system anyway, will be equivalent to the solution of the original system. And So what am I going for here now that I don't have all these fractions? Notice that this is in standard form. Number 1 is also in standard form. So I think I am going to look at the intercepts at least and see how those look. So if I'm just trying to find the x and y intercepts, for equation number 1, I'll just make a little table of 2 values for my x and y intercepts, okay? One is going to be the x-intercept, the other one's going to be the y-intercept. For equation number 1, to find the y-intercept, I let x equals 0. So I'm going to cover this with my hand, and of course you can still see it, but you can cover it yourself there. If I let x equals 0, then I have 3y equals 23. Okay. 3y equals 23. And that's when x is 0. So if I divide both sides by 3, then I'm going to get the y-intercept. That doesn't divide exactly by 3. 3 times 7 is 21. So this is going to give me 7 and 2 thirds, excuse me, 7 and 2 thirds. Okay, and I can just check that. 3 times 7 is 21, plus 2 is 23 thirds. Yep, that's right. So that's the y-intercept. And now I'm going to go the other way around to find the x-intercept by letting y equal 0, figuring out what x is. If I let y equal 0, then I've got 2x is equal to 23. Okay. 2 times 11 is 22, so this is going to be 11 and 1/2 for my x-intercept. That's kind of ugly, but it's not too bad for the intercepts. Yeah, it's a little ugly. Let's take a look at equation number 2 before I continue. As you'll notice, I have this graph over here without any scale on it because I wasn't sure how these equations were going to come out, so I didn't want to write a bunch of hash marks yet. Let's look at the intercepts for equation number 2. Again, I'm just looking at 2 points. I'm trying to find the x-intercept and the y-intercept. To find the x-intercept, we just put in, the y-intercept, we just put in a 0 for x. 0 on the x tells me where I'm going to hit on the y. That's why it's the y-intercept. Then I put in a 0 for the y and find the x. That's the x-intercept, where it's going to land on the x-axis. Okay, so I put in a 0 for x for equation number 2 over here. 0 for x, 2y equals 38 is what remains. And that does come out to a nice whole number, 19. So 0, 19 is the y-intercept. Somewhere, this is the highest thing I see so far, so that's going to be somewhere near the top on the y-axis. Okay, put in 0 for the x, equation number 2, for the y. There we go. And then you cover it up on your own, of course. And we get 7x equals 38. There we go. 7 times 5 is 35. That's as close as I can get. So I'm going to put a 5 here, and that's 3 away. Over 7 is what I'm dividing by. 5 and 3/7. So these numbers are kind of ugly to graph by hand. I'm going to be audacious and take a shot at it. Now, how am I going to get all the way up to 20? Let me just put 5 hash marks to start. 1, 2, 3, 4, 5. This is going to be kind of hard. I should have made those a little bit more separated, but that's okay. We shall see how close I can get. 1, 2, 3, 4. Now maybe you're thinking, hey, why don't we graph in the slope-intercept form instead of the standard form? And you can do that, but the y-intercepts are going to be just as ugly. Recall. So I'm going to call this 20 right here. And I'm going by 4s. 4, 8, 12, 16, 20. Okay. And we'll see on the x-axis, I'm not sure. I don't have to use the same scale on the x-axis, but I should go by the same type of increment. So maybe 2, 4, 6, 8, maybe 5, 10, 15, 20, or so on. And there are even special scales like logarithmic scales, but we won't talk about that just yet. So, okay, let me look at the highest value for the y-intercept I have. That's 19. So I'm going to put a little point right here. These are separated by 4s. So let's see. 2. I'm just going to make 4 little separations. So 1, 2, 3, 4 becomes the next number. All right. So that means 19 is right here. And this might turn out ugly. We'll see. The X-intercept is 5 3/7. Let me see. The highest X-intercept I see is 11.5 here. So, maybe what I can do is go by 2s on the x-axis. See, so I did use a different scale. 2, 4, 6, 8, 10, 12. I at least have to be able to cover what I've got showing. So let me stick with what I started with, equation number 2. The y-intercept was 19. The x-intercept is 5 3/7. So here's 2, 4, that's 6. So here's 5. And then between this little guy, if I wanted exactly 3/7, I would have to separate that into 7 little pieces, just between here and here, and then go 3 of them over and put a dot. Now 3/7, that's pretty close to 4/7. It's pretty close to well, 3.5 is exactly half of 7. So that's pretty close to a half. I'm going to say, oh, here's my pretty close mark. And right now, I'm praying that this graph is going to be accurate enough to produce the solution. As you can see, I'm having a struggle here. Okay. All right. And I'm trying to draw this by hand as best as possible. So this is equation number 2. Equation number 2. All right. Now let's take a look at equation number 1. The y-intercept is 7 2/3. Okay, so this is 4. That's 8. So 7 is somewhere in between there. Remember, I can separate these into 4 little pieces. I'll do it with this one. Okay, so here's 4, 5, 6, 7, and 2/3 is about right there. All right, and then 11.5 is, let's see, this is 10. So 11 is going to be right there, and 11.5 is right here. Now I'm going to try to connect these very smoothly, which is extremely hard without a ruler and without graph paper. And so now I want to know, what is that point right there? And I'm going to try to match it up as best as I can with what I've got showing. Okay. And so to me, it looks like that point matches up. This is 4 right there, with an x value of 4 and a y value of 5. Now, since I was struggling to create this graph, I should definitely check it. And if these equations were nonlinear, then you especially want to take that solution all the way back to the original equations. Since these equations are linear, I can get away with using this equation, number 1, and this equation, number 2, after I've cleared the fractions. And so I'm going to go ahead and do that. Equation number 1, here's my check, was 2x plus 3y, and that should come out to 23. So I'm just going to say 2 times 4 plus 3 times 5. So this comes out to 8 plus 15, which indeed does come out to 23. So that one's okay. That one checks out. Let's check equation number 2. It's got to work for both to be a solution to the system. Equation number 2, I'm going to use my 7x plus 2y, and that should come out to 38. So here's 7x was 4 plus 2y was 5, and that comes out to 28 plus 10, which indeed comes out to 38. So, all right, checked out. Whew. Especially on such a hard graph to draw by hand. So there's one technique anyway to start dealing with fractions. You can clear the fractions first, and then you might have a standard form equation. You might have a slope-intercept almost form equation. Certainly you can take it from the standard form and put it into the slope-intercept form pretty easily if you like that method better. Or you might end up with something in between, but at least you're looking at equations without fractions that might help instead of just trying to tackle this right away as it looks. So I hope this video helped. Stay tuned, there's more to come.